Okay, so for today's wonderful topic, we are now starting to delve into the world of objects. And so today we're gonna start talking about objects, really in the abstract a little bit. So far, the only concrete objects that we've seen have been strings and that scanner thing. What Java does with objects and variables is something that hopefully will peel back the hood just enough so that you can see what's going on. There is almost no end to how far you can peel back the hood. Ultimately, the computer runs your program using machine code, which are those zeros and ones. That's a bit too far. So somewhere between the high level of abstraction, which is writing a line of code, or writing any kind of program in code, which is basically a bunch of text, really just a bunch of strings, which as we've mentioned, the Java compiler turns into bytecodes, and the Java virtual machine turns into an executable program, which it then runs. So somewhere between the strings that we write as code and the machine language that the operating system itself actually runs is kind of an ideal level of abstraction. So hopefully that's what we'll get to. Okay, so one of the key points I want you to take away is to understand what an object reference is. And this is kind of a subtle thing about what exactly is that variable when we refer to it as an object. It's fairly straightforward to understand what a variable is when it's a primitive, but when it comes to objects, it's not so straightforward because objects are very complicated things. You should know how to invoke a method on an object. We've been kind of doing this, and be familiar with some of the string methods. Okay, so when we create objects, we will typically put them into a variable. And since Java is only a 99 and 44/100% pure object-oriented language, a variable will hold either a primitive value or a reference to an object. Now, notice the use of the term reference. That's important to understand what is actually going on, and to have some idea of how it can help understand things when it may not be completely clear. One of the things that I emphasize a lot, at least in the beginning, is how declaring a variable and assigning a value to it are two different things. And I like to, at least in the beginning, separate those two to emphasize the fact that they are different things. So we've seen what the different primitive values are and how we are only going to use a subset of those, namely ints, longs, doubles, and booleans. We will sometimes use chars a little bit, but as only when we're doing kind of very low level reading of and writing of files do we have to deal with bytes. And ideally, especially with some of the new things that Java has, we don't even have to go that far. So again, of the primitives, remember int, long, double, and boolean. Floats are to be avoided, as are shorts, and besides, the weather's too cold for shorts anyway. Bada boom. I'll be here all week. Okay, so now it's important to understand what this is. So when this is a perfectly legal declaration, but it's a declaration. And all this does is this simply says that the variable title is going to hold a reference to an object of type string. Nothing is created with this declaration. That's important to understand. Before we assign a value to this, do you know what is the value of title at this point? Like if this were in code, at this line, if we were to print title, do you know what it would print?
Undefined.
Yeah, you're correct conceptually. The undefined object-wise that it would create, that it would print is something called null. That's a keyword. So before an object reference gets assigned a value, it has the value null. And that is what is going to produce the most common runtime error you're going to get. And I promise you're going to get them. I get them on almost a daily basis. And that is something called a null pointer exception. And we'll talk more about kind of what is going on with that. So the important thing to understand, again, is that at this point, we've declared this variable to be of type of string, but we haven't assigned it anything yet, and its value is going to be null. The rules for primitives are also a little bit different because they depend on whether it's an instance variable, a local variable, or a class variable, and we'll get into that later. But just kind of put that aside for right now. Okay, so the object reference, well, this is actually technically, they say it holds the address of an object. Conceptually, we can sort of think of it that way. That's technically, that's sort of correct. It's correct enough for where we are right now. So we'll kind of look at that. The point is, the main point here, the object has to be created separately. The most common way that we create an object is with the new operator, and that is called instantiation. And sometimes we will refer to something as an instance of a particular class. So for example, after we've declared title to be a string, here we are now instantiating it. Now, all classes have something called a constructor, and the constructor is a special method that it basically sets up the object. Every class has a constructor, and that may seem obvious, like a law of nature, but it isn't. Because there are languages like C++ for which that is not necessarily the case. So, but forget any of that. In Java, every class has a constructor. Now, the strings are treated very specially. So now, string as a class, it has a constructor. So we can say new string, and what it takes is an argument that's already a string. So there's kind of a bootstrapping issue here. How do we create a string in the first place? Well, strings are very special in that we can instantiate a string not with this way, but by simply putting them in double quotes. And they have to be double quotes, not single quotes, as in some other languages, because single quotes are reserved for characters. If we have single quotes, they can only be put in, you can only put in a single character in that. Double quotes, we can put a string. So strings are special in that regard, in that they can be instantiated without the new. In almost no practical cases would you actually do this, but this is useful to understand because conceptually, this is kind of happening under the hood. Okay, so once we have an object we use the dot operator to invoke its methods. And you've already done that in the last assignment when you were invoking methods on the scanner class to read in the next integer in that particular case. But as you saw, we could read in the next string, the next Boolean, the next double, etc. So the class, in this case, the class string, defines a number of methods. And in this case, one of the methods that string defines is something called length. And what is that? That is an int that says how many characters are in that string. So the syntax is we use this dot notation. We have an object. We have an object dot method. And that is always how we do things when it comes to instance stuff. There's another type of methods called class methods or static methods, but we'll for right now we'll not worry about that. Okay, every method, or say it may return a value which can be used in an assignment, or if it returns void, then it can't. We can think of it as sort of asking the object to perform a service. Another way to think of it is as a behavior. Okay, so let's dive into what these reference things are versus primitive variables. So when it comes to primitive variables, it's fairly straightforward because primitives contain the value itself. But an object variable, it contains the address of the object. And by address, you just have to be a little careful. This is not the actual address in the hardware. It's the address in the virtual machine. So it's not an address you can actually access anywhere. I mean, in a sense, basically you really can't. So this is all under the hood. We have no access to this. And the reason I say this is because in other languages, like C++, for example, the object variable actually refers to the physical address of the object, and that can lead to problems. In Java, they have something called a sandbox, which kind of keeps you constrained from accessing the hardware from within the program. We can, and in those languages, they call them a pointer, but if you're used to what pointers are, then it's not the same as a C or a C++ pointer. We can just think of something that points to the address. Okay, so here's like if I have an integer, an int defined, say, as num1, and I've assigned it to be 38, then somewhere in the virtual machine is a place, one word long, that holds the number 38. Okay, so on the other hand, here's a string. It's called name1. The contents of that string is a string of characters. In this case, Steve Jobs is the string that it refers to. But you see this little arrow? The contents of the variable are not these strings, not these characters, but some number under the hood. We can think of it as an address that points to or refers to a place where these are stored. Okay, so you see the important difference. Okay, so now what does assignment do? Assignment takes a copy of the value and it stores it in a variable. So So for example, before, here we have one int with value of 38, another int whose value is 96. If we execute this statement that says num2 is equal to num1, what that does is it takes the value. Remember, all assignments, they take an expression. Now, remember, syntactically, there are two different things going on here. What's going on the right-hand side is an expression. This expression happens to be just the single variable num1, but it could be any expression which evaluates to an int. The left-hand side of an assignment statement is always just a single variable. Okay, so what happens after we execute this statement? Well, we take the value of num1, which is 38, and we stuff it into num2. And so now if we were to look at, if we could peer into where exactly these things are being stored, the value of num2 is now the same as num1. Now, the thing to understand here too is that these are still, even though they have the same value, they are completely disconnected. If I were then to say, if the next statement were to say num1 equal 5, then what would happen is the value in num1 would be changed to 5, but the value of num2 is going to stay exactly as it is. Okay, that may seem kind of obvious, but let's see what happens with object references. And this is why it's important to understand the difference, because if your program is acting kind of strange, then something like this may be going on. Okay, remember, for strings are objects. And so in this case, name1 is Steve Jobs, name2 is his buddy, Steve Wozniak. Then we execute this statement here. Again, remember that this is an expression, this is a variable. This takes the value of the reference of name1 and assigns it to name2. And so you see what's happened here? Now, both name1 and name2 refer to the same object. Okay, so that's something a little different. Now, once again, if I were to say name1, if I change that to, oh, let's make it his buddy Bill. Okay, so again, what that will do is that will create somewhere an object. Oops, come on. Okay, so then what that will do is that will say, now this points to Bill, but then name2 still points to the old one. Now, because strings are immutable, that's not so much of an issue. That is, because we can't change what's going on in this object here. But if this were a mutable object, then if we invoke a method on name1, then it would affect what's going on with name2. And again, that's something we're going to explore when we delve more deeply into objects. Okay, so in this case, in this particular case, kind of before, let's, come on. Okay, in this case, by the time we get here, name1 and name2 are aliases of each other because they refer to the same object. So in other words, there's still only one object here, and both of these variables refer to it. They can be, they can be useful, but you got to be careful. Now with strings, it's not going to be a problem because strings are immutable. But if we change an object through, if we change the object itself by invoking a method on it, then it changes everything for all of the aliases. Okay, and hopefully, if I get a chance, we'll try to show an example of that. Okay, so here's another thing to understand is that at some point, and this is something where that early languages like this wrestled with a little bit. Especially in large programs, you can be going along and then all of a sudden you can have an object that's been instantiated somewhere and there's no variable in the program anymore that has any references to it. In other words, the object has been created, it's taking up space in the memory, but there's nothing that you can, the program can't do anything about it. And in that case, it's called garbage. It's kind of useless. The term in non-garbage collected languages is something called a memory leak. And that's not something in Java we have to worry about in this context. Actually, we do have to kind of worry about it a little bit. But most of the people who have to worry about it in Java are people who come from other languages that are not garbage collected. And so basically, here's what happened. In a non-garbage collected language, it is up to the programmer to dispose of objects that aren't being used anymore. It's the programmer's responsibility. And in those contexts, a memory leak happens when you forget to dispose of an object. Why is that a problem? Well, because there's only a finite amount of memory, even with the large memory things that we have today. And so what a memory leak will do is eventually, if you have these unused objects that can't be referred to, they still take up space in the memory. And at some point you run out of memory. In other words, the program can't run because there's just no place to put anything. Okay, what Java does is Java has something called automatic garbage collection, or it has a garbage collector. And periodically what it does is it goes through and it identifies these objects that can't be referred to anymore. How does it do that? It actually uses a very sophisticated approach called mark and sweep, which is kind of better than the reference counting that older systems used. You don't have to worry about the details of that. Just know that Java takes care of it. And mostly it's something that you don't really have to worry about too much, other than in cases where you have a program that's using a lot of system-intensive resources, then you want to explicitly release those resources. So if you remember, when I was talking about the scanner class, because it was kind of using a system resource, a scanner object should always be closed when you're done with it. And what that does is that releases any system resource that it happens to be using. Typically, that might be a file. And just in general, when we're reading in from a file or even from the network, where we have a network connection, you want to close those because those consume system resources that can be scarce. Okay, so excuse me. Okay, as I mentioned, strings are really the building blocks of everything. In fact, if you think about it, all code, it just consists of a bunch of strings. And so programming consists of taking strings and turning them into executable programs. Because strings are special, they, you have to find some way of bootstrapping them. And so this is the way. And we've been doing this pretty much since day one. You've no doubt been doing it in your other languages as well. So we take some characters, we put them inside double quotes, and that becomes a string. This only works for string. So it doesn't work for anything else. So when the virtual machine encounters this, what it does is it takes a place of memory and it stores all of these characters. And then what will happen there as a string object. So as part of the string object, it contains basically an array of these characters way under the hood. But then it gets a reference to that area and assigns that reference, in this case, to the variable called title. Okay, so just understand that's what's going on. Now, once we have a string object, as I said, this is what's called immutable, meaning we can't change its value, we can't change its length, we can't do anything to it. Now, this is something which is, again, in older languages, what they would do is they would treat strings as an array of characters, but let you kind of mess with them. Through experience, they found that it's really a better idea to make strings just immutable, meaning we can't change them. So the methods in the string class can manipulate them, but what they do is they return a new string object that might be modified versions of the original. Okay, that's something important to understand. And that's something which, let's see, it's been a while since this kind of bit me a little bit, but it's something which I periodically forget every few years or so, every decade or so. And I'm trying to think. Yeah, no, about 5 years ago, I wrote some code where I'd forgotten that, and then I was I was expecting a string to be changed by something I was doing to it, and then just because I forgot that, and then it wasn't behaving the way I was expecting, and then strings are immutable. So just remember that. So strings actually have a whole pile of methods. Some useful ones are, well, and they're pretty well named. So toUpperCase will take a string and will return the same string except all of the letters were replaced with their uppercase values. toLowerCase is another useful one. It takes any string you have and it will replace all of the letters with their lowercase values. We'll see some examples of this. These I find to be very useful when reading in input from users where you want to allow the user to be case insensitive. You may have noticed that a lot of URLs are case insensitive, meaning that you can type something in all uppercase and then it'll work exactly the same. So under the hood, most web browsers aren't written in Java. They're usually written in C or C++, but they do something that's more or less equivalent to this. What's nice in Java, we can kind of do it in one fell swoop. The thing to remember is that it doesn't change the original one. Darn. Okay, this is another very useful one, especially when processing input data from input data where you might have to change a few things. So replace actually has typically 2 arguments, the thing you want to replace and then the thing you replace it with. So just as an example, if you're writing stuff to if you're creating databases, say if you're creating tables or columns, typically in those you're not allowed to use spaces. So there have been some cases where I've taken spreadsheets and if they're in the right sort of format, turn them into databases. And there it's like the columns of a particular sheet would be the columns in the database. But the problem is that spreadsheets allow you to use all kinds of stuff in the cells. So there would be typically spaces and other kind of characters. And so there, a heavy use of the replace. So for example, if there were spaces, I would go through and I would replace the spaces, say, with underscores. And that would be a way of turning a string that was not a valid column name into one that was a valid column name. Okay, length, as we've seen, this returns an int that says how many characters there are. That can be very useful. Substring is that's not something that I will occasionally use. Let's see, most of my use cases for that have to do with things like if the program is if I'm reading in a file from the system and I don't know what type of file it is. In other words, it could be one of a number of different types. That is typically designated as by the so-called extension. So like if you have an extension dot, let's say docx, for example, that's a Word document, or .txt is another common one, and .csv, say for a comma separated value. There are a whole bunch of others. So if you're reading in a file and you're looking at the name of the file and the program wants to figure out what type of file is this, then in basically looking at the substring for everything after the dot is one way, and comparing that with some known extensions is one way of figuring out what type of file it is. Another thing which comes in just only occasionally, I don't know if we're going to encounter this, but it is something which I have used from time to time, where well, let's look at a task like this. Supposing I'm looking at a C or Python type of variable name, like let's say a name, and this is a C or Python type of, darn, my mouse does this. Okay, this is, supposing I want to turn this variable, this into a Java one, which would be this. Okay, so I have to do a couple of things here. I have to basically replace the underscore with nothing, because Java names for instance variables don't use underscores, only static ones do. And then I want to, then here's where I'm going to have to use a character array. I need to change this N into an uppercase. And so what I would do is I would extract the character array, or actually, let's see, first I could replace the underscores with nothing, and identify what the what this N was, and then change that N to an uppercase. And there are character methods that will let me do that. So that's just, again, a use case for char array. So again, sometimes it's helpful to refer to a particular character, and the thing to understand is the index of the characters are zero-based. This zero-based, and this is something you're going to hear me complain about, because this is one of the well, I was going to say it was one of the dumbest things that modern programming languages do. That's a little bit too extreme. There was a really good reason why it was done originally in the C language. The C language was the first one that did that. Languages before that, like Pascal or Fortran, if you had an array, it would begin at 1. And C came along and said, well, let's begin our arrays at 0. And everything after that has just followed like lemmings over the cliff. Anyway, so you hear me complain about it, but there's nothing we can do. We can only complain about it. So in the string, hello, this is index 0, 1, 2, 3, and 4. Okay, and when we talk about arrays, we'll see how ridiculous this kind of gets. So how many, if I would say, what is the length of hello? It would be what?
4.
Okay, that's
5.
Okay, is it 4 or 5?
It's 5.
It's 5. Okay, so you see why it's a bad, the zero-based indexing is not such a great idea. 4 is a perfectly reasonable answer. Why? Because what is the last index of this string? The last index is 4. So what's its length? 5. Huh? So if you said 4, that is a perfectly reasonable answer, except that it's wrong. And it's wrong, it's not because of you, it's because of this stupid thing. That's why this is sort of silly. Or I have a string of length 10. What is the index of the last letter? 9. Okay, now that makes sense, huh? It doesn't make sense. It's stupid. All right, but we're stuck with it. All we can do is complain. So I will try to minimize my complaints, but this is the off by 1 error. What this is just illustrated is it's the off by 1 error. Especially when we start using arrays, this is something which will happen to you. It happens to me on a regular basis, not as regular as it used to, but it's the off by 1, meaning that the index of an array is always 1 less or 1 less than its actual place. Okay, so that's my complaint about it. All right, so let's look at this. Okay, so the main, this is the file from this is from the book, and let's see, am I going to have time? I might have time to do a little bit. Okay, so so here's a string called phrase, and here's our phrase. And then we're going to print the original string and then print the length. So again, let's sort of count it. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So I think the length is 20. Okay, so here's the first mutation. And that uses something called concat. Now, concat is actually, when you're concatenating strings, this is actually the preferable way to do it, rather than using the plus. But concat basically is the same as plus, except that it's a little bit more efficient. Okay, the second one is we're going to take mutation 1, we're going to take the whole thing and change it to uppercase. Here's an example of replace. We can replace, and replace is overload. We'll talk about what overloading is about, but here we can replace individual characters, and this will replace all of the E's with an X. And then this is where you the indexing gets a little bit wonky, and you have to be just really careful, because the substring will take, this will take from index 3 to index 29. So let's print them all and then print the length of the last one. So, okay, so here's the original string. The length of the string is 20. So here's the concatenated string, the first mutation. Here's where the first mutation was changed to uppercase. And then that one was changed. Notice all of the E's got changed to an X. So replace, that's important to understand, replace replaces all of them. Okay, and that's it. That's not obvious from the name. A better name might be replace all. And then the substring. Okay, so let's look at that. The substring was 3 to 30. Okay. So 0, 1, 2, 0, 1, 2, 3. Okay, so here's index 3, and notice that that is there. And then I think if you count, you will see that this, except this is actually index 29. Okay, so here's our little, what is produced by the following? So what is the length of space, the final frontier? So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 23, 24, 25, 26. Okay, so I'm going to guess 26. Okay, the substring. Okay, now substrings. The thing to understand is it goes from, if I only give it one index, it goes from there to the end. So that would go 0, 1, 2, 3, 4, 5, 6, 7. So that should be the final frontier, was what this would print. Now, to uppercase, notice that because I'm still doing it on the original one, this will produce an uppercase of the whole thing. And even though I've taken the substring, the length will still be 20. It should be 26. So let's see if that's okay. 26. Okay, the final frontier, uppercase the whole thing, and the string is still 26 because we have not changed string. So this right here created a new string, in this case, this string, and returned it, and all we did was print it, but it did not affect this. And likewise, when we made it uppercase, that created a new string, and we printed that, but it did not affect string. If we were to print string again, it would still look like this. Okay, I see I only have a few more minutes here. But I don't really have time to do well, let me just do sort of a quick demonstration of what to do. Let's see what. Let's see here. Okay, so if you notice that I've been my videos on this have actually been with a Windows partition I have on my Mac. As you can tell, I'm kind of a Mac guy, but that's okay. Windows is perfectly fine. However, if you notice that I did add some things, but I have not pulled them on my Mac. So this is how you, if I change something in my class code, and then here's how you can pull it down. So hopefully this will work. I'm doing this live without a net. So what you do is you will typically have your project will be down here. But if you have my project, the class code open, what I just right click at the top of the project, select Git, remote, pull, and then just make sure that in this case that this is mine, not yours. Okay, so and then so you see the U there, that U says that it's going to be updated. And so if you remember, I did this this other little example, and what I just showed you was how to pull that down. Let's see, I have 5 minutes. Let's see if I can do this in 5 minutes. Let's do a, oops. Let's just do another little example of the strings. Okay, so I got a string. And let's just sort of see what it is. Now, what I'm also trying to illustrate here is that I encourage what I call baby steps. So write a little bit of code and then run it, and then make sure that it works. If you write a whole bunch of code and then it doesn't work, then you don't know where to start. So, all right. So so I wanted to illustrate that. So let's do this. Let's do to uppercase. Okay. But now let's fat fingers here. Okay, so you notice that okay, so the variable test, okay, I did it to uppercase, and this is kind of where the gotcha can come in. I made it uppercase, that returned a string that was uppercase, which I was able to print, but it did not affect my original test. Now, what I can do is, let's make it to lowercase. Oops. Gotta stay. All right, so now am I allowed to do this? Well, I have no red squiggly of death, so it says I'm allowed to do this. All right, so let's just sort of unpack the semantics of this. What goes on the left side of an assignment statement? An expression. What is this expression? This expression takes the string test, which at this point is this string right here, and invokes this method on it to lowercase, which will return, well, let's make it uppercase, because there's only one upper. Okay, so this will return an uppercase version of this, just as we did here. And then it will change the variable test to that new uppercase. So now when we print test, okay, so now the variable test has been changed because I assigned it a new value. That is the only way that I can take a string variable and change it to something else. Okay, so it's now 11:50. So that is that.